Welcome back, dear viewers. In this video today we are going to discuss about some testing of switchgear. So in this video we will discuss about three important tests of switchgear. The first one will be IR, insulation resistance. The second one will be CRM, contact resistance measurement, and the third one will be the timing test of switchgear. So let's start from the insulation resistance test. So first of all, why we are carrying out this test? So the purpose of this test is to check the healthiness of insulation of an electrical equipment. Whatever will be the equipment of electrical, there must be a insulation, and insulation is capable to sustain up to its design voltage. So we are checking the healthiness of insulation by carrying out this insulation resistance test. And for carrying out this test, insulation testers, this one is the tester of Mega company. So for this carrying out this type of test, we are using insulation testers which are provided with different voltage ratings like 500 volts, 1000 volts, 2500 volts, 5000 volts, etc. So these are the different options available to this type of insulation resistance meters. For carrying out, we have to inject the particular voltage to equipment as per the equipment's voltage rating. We will understand this by this example. Suppose the breaker rating is 430 volt, means it is a LT breaker. So for this LT breaker, the DC injection voltage, means the insulation resistance test, we will carry by 500 volts of DC injection voltage. And suppose the breaker rating is of 6600 volts, means the 6.6 kV AC, then the DC injection voltage will be 5 kV, means 5000 volts. So you have to inject the DC voltage up according to the breaker AC voltage ratings. Again we understand this, why we check the insulation resistance, why it is the particular requirement to check the insulation resistance. So first of all, any electrical equipment's insulation is being made. As the time goes forward, the insulation starts to aging, and the chemical reactions and the temperature of the electrical equipment or electrical insulations, these two processes makes the aging process fast. Due to these processes, the insulation becomes weak, and thereby there is a chance of damage of the equipment and also as well as person safety. So that's why that's why we have to check the insulation resistance. So now we will discuss how we check the insulation resistance test, means how the connections are made, and at between which points we have to inject the DC supply voltages. So you have to inject the DC supply according to the voltage level of equipment. So you decide the voltage ratings, and then there are two positions of breaker. One is the closed position and one is the open position, as you can see here. So in the closed position, you have to inject the DC supply between the phase to phase connection, means the R or Y or B, or R and B connection, and between the between the phase to earth connection. So R to this earth connection, Y to this earth connection, and B to this earth connection. So in breaker closed position, you can check IR by these three steps. and the second one will be the breaker open position. So this is the breaker open position, and here you have to inject the DC supply between the breaker poles. So this one phase consists two poles. One is R dash, Y dash, B and B dash. So you have to inject the DC supply between these poles, and the duration for this injection of voltage of time is 1 minute time. During for the 1 minute you have to inject the DC supply. So now we are discussing that why we are injecting the only DC supply. Means we can check also we can also check the insulation resistance by injecting AC supply also. So we are supposed to find the insulation resistance. We have to find this value of R and not the value of Z. Z is the impedance. So impedance is the total vector sum of resistance plus inductance plus capacitance. So if we inject the AC supply, then inductance and capacitance of the insulation will also be added with the resistance. So impedance Z will be calculated. You cannot measure the R. You cannot measure the resistance if you inject the AC supply. So that's why we are injecting only the DC supply. So DC supply will only measure the resistance. DC supply will not measure the capacitance or inductance. And the second reason, that if we inject the AC supply, the electrical equipment will start to function as it is intended for use. For example, we are injecting 5 kV AC supply to motor of 6.6 kV rating. Then the motor will be charged and will start to run if we inject AC supply rather than DC supply. So this is the basic why we are injecting only the DC supply. Now talking about standard value for insulation resistance test. So the standard value is kV plus 1 mega ohm. Here the kV is the voltage rating of equipment. Suppose we consider 11 kV panel breaker for this example. So as per standard, its IR value should be at least 12 mega ohms. 11 kV, here you put 11 plus 1, so it becomes 12. So if the IR value of this breaker panel is less than 12 mega ohms, then it is not acceptable value. And suppose its insulation resistance value is 15 mega ohms, which is greater than 12 mega ohms, then it is acceptable. So this is the standard value of insulation resistance test. Now the second test, breaker contact resistance measurement test. So in this test, first we will discuss that why we are carrying this test. So to find the resistance of breaker contact where moving contact and fixed contact meet each other. So in any breaker pole inside, there is one fixed contact and the second one is the moving contact. When these two contacts meet each other, so here the resistance of that contact, we have to calculate the resistance of that contact, and this resistance of contact should be as possible as low. Why it is low? Because circuit breaker is to carry high currents. Circuit breaker has to carry high currents, and if the contact resistance will be high, then the energy losses, according to the I square R, the energy losses will be more and the breaker will not able to pass the high currents. So that's why the contact resistance value should be as possible as low. Now by carrying this test, what we will come to know? By carrying this test, we will come to know about the looseness in the contact, mean at the joining point of contact if there is any looseness. So due to looseness the resistance value will become high. So we can come to know about the looseness in the point of connection. If any corrosion that is present at the contact surface, any other contamination in the contact, and this test if all the values all the contact resistance values are within the limit, then this test shows the healthiness of the contact, means there will be not any issue to pass high currents from this breaker. Now we will talk about procedure for breaker CRM test. So for carrying out this test, one kit called CRM 100 is available of Scope company. In the kit, it uses the method of 4-wire Kelvin DC voltage drop test method. Here 4 wires are used, from 2 wires used for the current injection and 2 wires are used for the voltage measurement. Here we will inject 100 amps DC current or higher than 100 amps DC current, because higher is the current injection, the lower will be the resistance value we will get according to this equation of V is equal to IR. So this is the connection of kit to the one breaker pole. As you can see here, the breaker is in closed condition and here two wires are connected for current injection, one at upper side, one at downside, and two wires are used for voltage measurement, one at upper side, one at downside. So this is the connection for breaker CRM test. Now talking about the result values, the resistance we here get will be between 15 to 20 micro ohms, or you can match these values to the factory test of breakers. All the three breaker poles resistance should be same, because if any discrepancy in the contact resistance will not be good for carrying the high currents for a breaker. And here the resistance value we will obtain depends upon capacity or the voltage rating of the breaker. Now the third test is the circuit breaker timing test. So here purpose of the test is to calculate the time that is taken by each circuit breaker pole while opening or closing operation, so as to check the proper function of the circuit breaker. Circuit breaker closes and opens according to the requirement. It closes upon the command and opens on command or any other tripping. So we have to calculate the time taken by each of the circuit breaker pole. There are 3 circuit breaker pole according to the phase RYB. So we will calculate individual pole timing values. As we all know that circuit breaker is important in maintaining the reliability of power system network. If the circuit breaker has not operated within the time limit, there will be adverse effect in the power system network. If the operation time during a trip is too long, then the short circuit current being interrupted will persist for a much longer amount of time in the circuit breaker. The more time it takes, the more damage it occurs. It the more damage it will create to the power system installation, and which leads to the shortest lifespan of electrical apparatus. So that's why the timing test of circuit breaker is important, and we are calculating its timing values. Here also the three circuit breaker poles must operate in sync with each other within the time limit. The time limit between the circuit breaker poles is 5 milliseconds. Here all the values of the timing test you will obtain in milliseconds of time. The circuit breaker operates in milliseconds. So we are talking about that here three poles must operate in sync with each other within the time limit. Otherwise, the slowest contact and the quickest contact will have to pass more energy, which will result into damage of the contact. If there is a discrepancy between the circuit breaker poles to operate, means first one and second pole has operated but the third pole is delayed in operating, or the any of first if any first pole has operated very fast and the second and third pole has operated delayed. So in that moment, the first means the slowest means the quickest pole, and the slowest means the third pole will have to pass more energy. So due to it will result into damage of the contact. So that's why there is requirement to operate the three poles in sync with each other. Now we will talk about that procedure for timing test. So this I have shown is a kit called Scott MXP of Scope company. So by using of this test kit, we will carry the timing test. This kit calculates the time from the initiation of closing or opening command up to joining or separation of contacts in all three breaker poles individually. So here if you can see, here the connection points are available. Here the display is available to show the timings. Here the closing opening commands buttons are available. This is the power switch of kit, and here the control cables of command is available. So here 6 wires are used for breaker pole connection, 2 wires are used for breaker command, and 1 wire is used for positive voltages. You can understand by this figure that here one positive point is available, one closing coil point is available, and one negative coil point is available. This display shows the millisecond timing of circuit breaker operation, and here the command buttons are available for giving a command of open and close, and here RR dash, YY dash, BB dash poles connection we have to connect. Suppose if we are to carry open command, so one positive point and closing point, this will come into picture, and it will give command to circuit breaker for close, and up to and from the time of command up to the joining of the contacts. This timing will be calculated by the timing test, and the same is applicable for opening operation. Now talking about the timing test results. The timing test results for closing operation is near about 45 to 55 milliseconds, and for open operation is about 30 to 40 milliseconds depending upon type and capacity of the breaker. Here one thing is to note that close operation time will always be more than the opening time of breaker, as tripping should be very fast for fault isolation. So if you carry a timing test for a circuit breaker, you will get the values of tripping time that will be lower than the closing time of operation. For closing operation, there are various interlocks through which finally close command executes, which is like series connection of breaker. So in the closing operation, there are interlocks like a spring is charged or not, a relay, numerical relay is healthy or not, master trip relay is reset or not. So these are 3 to 4 interlocks come into picture while closing command, and for due to this the it is creating like series connection of command. So that's why the closing operation takes some more time than the opening operation. And talking about the opening operation, there are not such any interlocks through which finally trip command executes, which is like parallel connection. If you see the tripping circuit of any circuit breaker, then you will see that there are parallel connections are given for tripping of circuit breaker. If any relay is giving a trip command, then also the circuit breaker trips. If any if any emergency push button or remote any trip is available, then it will also trip the circuit breaker. So there is not any such type of interlocks available for opening or tripping operation of circuit breakers. So that is the main reason why we are getting the closing operation time more than opening operation, and the opening operation time is less than the closing operation of circuit breaker. Thanks viewer for watching my video, and request you to plant a tree and save our planet if you really like my video. Thank you so much. See you soon.